Hello everyone, welcome back to the channel. Today we're diving into a topic that's quietly reshaping the future of air combat. It's not about stealth coatings or futuristic missiles. It's about something far less visible but far more decisive: engine innovation. Sixth-generation fighter jets are being designed to dominate airspace for decades. They must fly farther, faster, and smarter than anything before them. At the center of all that capability sits the engine. Israel's strength in aerospace innovation gives it a unique edge in this race. While it may not always build entire fighter platforms alone, its engine-related technologies influence how these aircraft perform at the limits of physics. Modern air combat is no longer just about speed or agility. It's about energy management. The aircraft that can generate, store, and direct energy most efficiently gains a lethal advantage. Engines are no longer just propulsion systems. They are power plants for sensors, electronic warfare, directed energy weapons, and AI-driven flight systems. Israel understands this shift better than most. One of Israel's key advantages lies in its experience-driven design philosophy. Israeli engineers build systems with constant real-world operational feedback. This leads to engines optimized not just for theory, but for survival. Sixth-generation fighters demand variable-cycle engines. These engines can change how they operate in flight. They balance fuel efficiency, extreme thrust, and thermal control in real time. Israel's research institutions have made major advances in adaptive airflow systems. These systems allow engines to switch modes seamlessly. That flexibility is critical in future dogfights and long-range missions. Thermal management is another battlefield. Stealth aircraft generate enormous heat. If not controlled, that heat makes them visible to sensors. Israel has pioneered advanced heat dissipation materials and designs. These innovations reduce infrared signatures dramatically. That means enemy tracking systems struggle to lock on. In modern combat, being unseen is often more powerful than being fast. Israeli-developed ceramic matrix composites play a key role here. These materials tolerate extreme temperatures while remaining lightweight. Engines using them can run hotter and more efficiently. Higher operating temperatures mean more power. More power means better acceleration, higher sustained speeds, and greater electrical output. All of this translates directly into combat dominance. Fuel efficiency is another critical factor. Sixth-gen fighters must operate across vast distances. Israel's work on combustion optimization reduces fuel burn without sacrificing thrust. This allows fighters to loiter longer in contested airspace. It also enables deeper strike missions without reliance on vulnerable aerial refueling. Endurance becomes a weapon. Israel's experience with compact, high-output systems gives it an edge. Its engineers routinely design components that deliver more power from smaller footprints. That's essential for next-gen fighters. Electronic warfare systems are power-hungry. So are advanced radars and sensor fusion platforms. An engine that can support these systems without performance loss becomes a force multiplier. Israel's engine-related innovations often focus on modularity. Components are designed to be upgraded rapidly. This allows aircraft to evolve without complete redesigns. In sixth-generation warfare, adaptability is survival. Threats change fast. Engines that can accept upgrades in materials, software, and control systems stay relevant longer. Digital engine control is another Israeli strength. AI-assisted engine management systems can predict failures before they occur. This dramatically improves reliability and mission readiness. These systems also optimize performance in real time. They adjust thrust, cooling, and power output based on mission needs. Pilots gain an aircraft that feels almost alive. Unmanned and optionally piloted fighters are central to sixth-gen concepts. Engines must be autonomous. Israel's experience with drones directly feeds into this capability. Autonomous engine operation allows for extreme maneuvers. It removes human limits from decision-making loops. This can mean the difference between victory and defeat in seconds. Israel's defense ecosystem encourages rapid iteration. Military, academia, and industry work closely together. Engine innovations move quickly from lab to flight test. This tight feedback loop shortens development cycles. While others take years to refine concepts, Israel compresses timelines. Speed of innovation becomes strategic power. Another critical area is survivability under damage. Israeli engine designs emphasize redundancy. They are built to keep operating even after partial failure. Battle damage tolerance is essential in high-threat environments. An engine that can limp home after taking hits saves aircraft and pilots. That resilience changes mission planning. Israel also excels in software-hardware integration. Engines are no longer mechanical systems alone. They are deeply digital platforms. Software-defined performance allows rapid tuning for different missions. Air superiority, strike, or electronic attack profiles can be loaded instantly. One aircraft becomes many. Directed energy weapons are coming. Lasers and microwave systems demand enormous electrical power. Israel's engine innovations are already accounting for this future. By generating surplus electrical capacity, these engines prepare fighters for next-gen weapons. This ensures relevance in conflicts that haven't even been imagined yet. Israel's strategic environment forces constant readiness. This pressure breeds innovation. Engine systems are designed for high sortie rates and minimal maintenance downtime. Simplified maintenance increases availability. More aircraft ready to fly means greater deterrence. In modern warfare, presence alone can shape outcomes. Israel's contributions often integrate quietly into multinational programs. Its engine technologies influence platforms flown by major powers. The impact is larger than it appears. Cyber resilience is another overlooked aspect. Engine control systems are potential targets. Israel's cybersecurity expertise strengthens protection at this critical level. A hacked engine is a grounded aircraft. Secure systems ensure fighters remain operational even in contested digital environments. Materials science remains a cornerstone. Israel invests heavily in nanomaterials and advanced alloys. These materials extend engine life under extreme stress. Longer engine life reduces costs. It also increases operational confidence. Pilots trust their machines when they've proven durable. Noise reduction is also evolving. Quieter engines reduce detection risk. Israel's acoustic research contributes to this stealth dimension. Lower acoustic signatures matter during low-altitude operations. Surprise remains a timeless advantage, even in high-tech warfare. Israel's compact geography demands efficient takeoff performance. This drives innovations in thrust-to-weight ratios. Engines must deliver maximum power quickly. That same capability benefits carrier and dispersed operations elsewhere. Shorter runways and rapid launches expand operational flexibility. Export controls limit how much is publicly known. Many innovations remain classified, but the pattern is clear through performance outcomes. Allies seek Israeli input on propulsion-related challenges. That trust reflects a proven track record. Engine innovation becomes diplomatic leverage. In sixth-generation warfare, air dominance is about systems integration. Engines sit at the heart of that system. Israel's holistic approach gives it a lethal edge. This edge is not flashy. It doesn't always make headlines, but it shapes every second of flight performance. When a fighter accelerates faster, sees farther, and powers more systems, the engine is the reason. Israel understands this better than most. Future air battles will be decided before missiles are fired. Energy, power, and endurance will define victory. Engines determine all three. Israel's engine innovation ensures its fighters enter that future prepared, not just to compete, but to dominate. That's why propulsion is more than engineering, it's strategy. And in that arena, Israel holds a decisive advantage. If you found this breakdown insightful, stay tuned for more deep dives into the technologies shaping modern warfare. The future of air combat is already here.